Hello again. This time I want to talk about circuit diagrams and circuit symbols. Obviously, once you've built a circuit, you might want to tell somebody else how you've designed it. You could try drawing a picture of the circuit, but to be honest, that's quite hard and it's a bit labour intensive. So what we do is we have some standard symbols that we use to stand for different things, and everybody knows them, so we can share our ideas that way. Now, the things that we can connect in a circuit like this, it's a light bulb, they are called components. So anything that can go into a circuit is called a component. And we have certain symbols to stand for each of them. So we'll start off with the most basic. Now this is a cell. Okay, it says cell on the side of it, green cell. This is basically what most people would call a battery. Technically it's called a cell. And the symbol for that is this. That's a cell. And it has a plus end and a minus end, positive and negative. And if you look carefully, you can actually see it says plus on here and it says minus on here. So the minus end is this end and the plus end is that end of the cell. When you put lots of cells together, one after the other, we call it a battery. So this is 4 cells together, and we call this a battery. Now, the symbol for a battery is this. Okay, so that's a battery. And again, it has a plus end and a minus end, a positive and a negative end. Normally we don't draw the plus and minus, but that's the way around they are. The big end of the symbol is the plus end. The next component, next most obvious one, is a light bulb. They come in all shapes and sizes. So these 2 different size light bulbs, but they all have the same symbol, and it is a circle with a cross like that. And it's either a light bulb or a lamp. Okay, that's the symbol for a light bulb. You notice all the symbols have got wires sticking out of them. The wires are just to connect them to something else. The actual symbol for the lamp is the circle. The actual symbol for the cell is these 2 lines, but we connect them with wires. Next one. This is a switch. Okay, I don't have any wires connected to it, but this is a switch. It allows you to switch the current on and off. And the symbol for that is just like an open door, like that. So it's a switch. This switch is shown in the off position because there's a break in the wire. If we close the switch and make the switch switched on, then this would move across to here. But we normally draw switches in the off position because otherwise you can't tell that they're there. Occasionally you might have some little blobs like that to show that there's a point where they contact. Okay, and the last one I want to look at, there are quite a few others, but we're just going to look at this last one. This component is called a resistor. Okay, we'll deal with why it's called a resistor later. And it should be fairly obvious why its circuit symbol is the way it is. If you look at that and then compare it with its circuit symbol, this is a resistor. Okay, so those are the main components. And I'm just going to put 2 others in, which are commonly used, but they are actually just for measuring. So they pretty much look the same. This is an ammeter. Okay, it doesn't say it's an ammeter, it's actually a multimeter. It does all sorts of things, but I'm going to label it for now amps because I'm only going to use it as an ammeter. So I'm going to put a label that says amps on my ammeter. Okay, and the symbol for an ammeter is a circle with an A inside it. So that's an ammeter. And the other circuit component that I've got is very similar. In fact, it would do the same job, but it's a voltmeter. Okay, so I'm going to use the yellow one to show volts, and the ammeter is the grey one. So this one is going to be labelled volts. Again, I can use it for all sorts of things. It's got multiple connections, so I'm going to call it voltmeter. Okay, so this is measuring volts. And the symbol for a voltmeter, like the ammeter, is a symbol with a V inside it, so voltmeter. So those are our circuit symbols. How do we join them together to make a circuit diagram? Well, the key thing is that the actual connections have to be in the same order as they are in the real circuit, but we lay everything out so that it's in nice straight lines. So if I wanted to connect my battery, this is my battery and I connect it to my light bulb. Here we go. There we go. I've got light bulb connected to the battery. We have the negative of the battery, positive of the battery. So I'm going to draw it this way round. And then we have nice straight wires connected to my light bulb. Okay, if I was to connect another light bulb across the battery at the same time, so let's try this one. Now I'm going to have to hold it in place because I don't have the right connector. Okay, so I have this connected at the same time. Then I've actually joined it both to the terminals of the battery. So I have another light bulb connected to here and here. So I'm just going to switch that off because it's a little bit bright. If there's more than one thing connected to the same point, then what we do is draw it like this with a dot, sort of a fairly large dot, showing that we've actually joined two wires together at the same place. So here we have the negative of the battery. So we've got the negative of the battery, follow around with my finger through the first light bulb back to the positive of the battery. And the negative of the battery also goes through another joint through this light bulb, through this wire, and that joins back to the positive of the battery here. Okay, so that circuit is laid out in exactly the same way, but there's nothing to stop me, so long as the connections are the same, flipping it around and rearranging it to make it look a little bit better, but so long as all the connections are correct. So I could draw the same circuit. I could flip my battery upside down as if it were like that, looking from the back. And I could connect the two light bulbs. Here's my first light bulb. And here's my second light bulb. Now, if I've traced around all the circuits with my finger, it should be exactly the same. I can trace from the plus of the battery through the first light bulb, back to the negative, and I can trace with my finger through the second light bulb and back to the negative. If I do that with my first finger, from the plus of the battery through the first light bulb to the negative, and also from the plus of the battery through the light bulb to the negative. So this is exactly the same circuit as this one. It's just laid out in a different arrangement. Now, the other way that we can join up a circuit, okay, I'll take two light bulbs this time and join them together, not one across each other like that. I'm going to join them together so that we have them one after the other. And you probably all know the name for that kind of circuit, which is a series circuit. Let's try. And then that one is going on to here. Okay, so we now have two light bulbs. We've got positive going through one light bulb, then through the joint to the next light bulb, and then through and back to the negative. So if I drew this one out, I'm going to put the plus of the battery up the other way, so as if I'm looking at it that way round, because just conventionally we like to put the plus at the top, is normal. So plus at the top. It's not absolutely essential to put the plus at the top, but it's just very much more common. Then I said that I went round through the first light bulb. Then the wire from the light bulb goes to the next light bulb. And then the wire goes to the negative of the battery again. So that's my new circuit diagram for this one. Let's just switch these off so they're not so bright. Anyway. And these are two different arrangements that we can have of a circuit. This one here, the two components, the light bulbs, are connected one after the other. There's only one wire that effectively goes through that one and then through the next one. And we call this series. So when two components are connected literally one after the other like that, we say that they're in series with each other. So the two lamps are in series with each other. Sometimes we call it a series circuit, but really just those two light bulbs on their own are actually in series with each other. This one, we call it parallel. The two light bulbs are actually connected effectively independently to the same place. And any time when you get two components that are connected in this way, forget the battery for the moment, but the two light bulbs, one end of the light bulb is connected to the one end of the other light bulb, the other end of this light bulb is connected to the other end of this light bulb. They're both connected to each other in that arrangement. If I draw two components, like a resistor, a light bulb and a resistor, and I draw them parallel to each other like that, and then I join up the ends like this, and I take the wire from here, say, onwards, then these two components we say are in parallel with each other. So we sometimes say that this is a parallel circuit, but more fundamentally than that, these two components are in parallel with each other. So any two components which are joined in that way, we say they are in parallel. So that's the two main designs of circuit that we can talk about. Parallel and series. It's very important to get that distinction because the way we connect things makes a difference to how much current flows, what voltages we get. Where we connect things, like an ammeter, you have to connect in the right way. You have to connect an ammeter in series, so in line with things. You have to connect a voltmeter in parallel, which means across things.